Okay, now we go to the next level. That's how we talk about introduction. Now we talk about the way how to do it. As what I said, meditation of finding, learning, of failure, versus, right? And then we have to identify the causes of the failure, right? From then, we can make improvement to the product. We can make improvement to the product. Evolution of the product will just come by itself. People don't say actually, I want to improve this, I want to improve that. There must be something that is essential, the motivation to make them want to move to the next level because they want to go to the next. Okay. So the concept of failure analysis is not something like actually, maybe you used to know and you used to listen because I said traditionally find out how the failure occurred, as what you said just now. And then we do the process of failure, right? And then regarded as development, conversion, development, and management is very important. Because whenever you have failures, right, you analyze, you remember this, very important. Maybe you don't be a failure engineer, you're going to be a product engineer, you're going to be a process engineer, you're going to be a equipment engineer, you can be many types of engineers. As an engineer, your function is to engineer. Engineer is the name, engineer is the work. Something that you have to do. When actually you want to improve something, you see that actually China, for example, is the mega project that they can make the push to be far distance before they have a column to support it. Right? Even if you look at the highway just now, you took the highway when you drive, you look at L1. Last time, they must have one column at the center of the two highways, right? And then they make the bridge. Okay? So, as a failure analysis, they say, maybe that, at the center of the two highways, you have a column there. This actually is not good, right? Whenever the motor is going through this thing, the column is. And then that's actually a very big thing. So, what happened nowadays, they analyze. How to make the bridge not to have the column or the support at the center of the highway, right? They just want to make even how big, how wide is the highway. They just want to make one. Right? This is based on the integration of the analysis that they analyze, right? To be the something that they have to make improvement. So this regarded as the part of the product development. Right? They have to without understanding the product. Okay. So let's take a look at this cause and effect. If you are injured, right? What cause of injury? Before. Why? Sleep. Why is sleep? Because of the why? Why is sleep wrong? Sleep failure. What's sleep failure? You sudah dengar dan bangau kan? Sampaikan menjemput default tak makan aku sebut right? Bangau sampai kubur sebab hujan tak panggil aku semua. This should be a right understand about the cause of that. Right? You can sing the song, but then you realize the song actually very easy. Right? Until you understand the cause of it. Yeah, next. Okay, when you look at it, effect caused by action by condition. Okay, this is the elemental cause itself, and then the effect, caused by the example action, condition. So you must be like mesh strike, what is the condition, mesh disease, and so on. And this is something like the elemental cause itself. That is something that but then so the elemental causes, the fundamental cause, element that made up of effect, that is the cause. condition or parameter from which the failure event was short-term solution, but then the root cause of the process or procedure which went wrong or wrong. That's why I say as engineer, you panggil UPS, unit process sustaining engineer. You do the process, but after 2 years even you give up. You want to change job because you do the same thing almost every day, right? You don't make so much improvement because that's what you are, you see. So you get bored, you change company, you go somewhere else. But honestly speaking, if you go to the level that whenever there's an issue in the industry, work together with the engineer until you can understand the cause, that this is long-term solution so you can go to other things. That is very important. Because when I was with the industry, many things that I would like to be a process guy because I say I'm bored. So I try to understand really. And with the asset engineer, I go back, open up, read the books that I have last time, and I like the mathematical function to understand the root cause of it. Right? But I was next. Okay. So for example, cause of the root cause. If you see the building collapse, and then not actually the music is the use of poor quality of cement, but better engineering with just a root cause, right? Maybe the root cause of budget constraint. Because of budget constraint, that's why in the process of doing the subcontractors, they try to reduce costs in this material. Whatever the engineering design that you come up, it's not at the price. Or maybe you can first time the supply of the engineering. Alright? So this is something that you have to take a look at it. So the difference between the primary cause and root cause, or primary cause and root cause. So this is very important when you work as an engineer with the one. You will be able to go to the next level. That's very important. For example, primary cause, set of condition of parameter, finish of the machine part was not as specified. Okay, so the root cause, the failure to check the finished product after part of machine. So they do the QC, quality control, right? So the other one is the corrective treatment was applied. Okay, the failure to ensure that the people from there has some control of changes in the temperature to quality the design and mechanical properties. One classic example recently that in the industry I can repeat. You learn about sintering, right? Sintering. So tell me you learn about sintering. Powder methodology sintering. They have issue that they are not able to during the sintering they cannot make the materials react connected among each other as a particle, right? And it's something to do with the heat treatment. No matter what, they not be able to do it. And then they say, oh, heat treatment. They try to keep the temperature, no, they try to do this, not okay. But then, fundamentally, they have to take a look about how the materials are in contact for them to be used among each other. That's interesting, So that's another class that but then it's not fundamental that you learn something. Okay, corrosion and cracking, like implementation of that line to control corrosivity of environment during one classic example, KDA analysis, proton saga, very your the proton saga, the body. Sometimes you can see a lot of spot rust. Nampak tak rust dengan potato? They rust. And that's the failure analysis. Right? And then people try to find out what is the root cause of it. Honestly, it's simple. When they do welding is they cannot use under normal environment. Not to dipanggil medical inert gas and so on, right? because they want to take a look at how the welding was done. You melt the metal, and then when you melt the metal, you don't want to introduce oxygen. Our environment is oxygen, right? You know, when oxygen, they become oxide. When oxide put together with metal, ferrous, becomes ferrous oxide, and then corrosion. Right? That's why we call it metal inert gas. So where's the inert? Inert is nitrogen, you know, and other gas. So at the time they say, oh, you will without inert gas like that. At the time the engineer, you know, may not have kind of knowledge that you have now. Right? You will. Oh, I can weld. You know, very good. I can weld. Okay. But then the effect, it failed. The spot welding will corrosion. You know, because the effect you can see immediately, right? It's something that, you know, you have to do the failure. Why is corrosion? And then you know how to prevent corrosion. It's very important. Yeah? So that's why now the people don't use the iron for the car anymore, and then they double that, they don't use it to the truck. Next. So when you know one day you join you know industry or something, they have to take a close failure management relationship, the knowledge of failure management can be applied, and lesson that can be implemented. You know, in the industry, whenever you send a product to the customer, and then customer see the product fail and they are failed, they will send it back to you. They will send it back to you, and then ask you to answer why you know the device that sent to them failed, and you have to come up with a report. They call it AD report, AD discipline report. You know the AD discipline report, they have to write, they have to explain until the customer satisfied. Right? And then you will be one of them because you know when you go to industry, you really have to analyze it. That's why actually they must have kind of also failure management. So they know how to reduce the prevent the failure. Right? Okay, that's important, yeah. And then the component of this really like failure management, investigation, the report, the lesson learned. Not to make it perfect, but on this speaking, it's not really happening. They can come out, you know, with all the words, but then the problem comes with it. Because whenever they analyze the failure, they don't analyze using the right tool. And I'll show you later. Next. Right? So this what actually the concept you can take a slide later on. And then they say actually, you know, step on the total failure management is like failure mechanism investigation, you know, all this kind of analysis, and then ensure correct risk evidence, and then they final report, and then the implementation. This one they have to do. So they have to answer to the customer, right? You know, that case when I work with National Superconductor, there's one space shuttle. I don't think you know that time. You heard about the name of space shuttle Challenger? Challenger terbakar masa dia nak launch dan outer space. Tak pernah dengar kan? Okay, when they did not, I used to work with this company, and then they asked us to come up with the AD because they suspect the product is uncommon. Right? And come up with the AD report. How? But then actually, otherwise we will be sued with $5 billion on this kind of thing. But there is a discipline that you have to write. That's why you write report there, you have to learn from the report, right? Because in the future, we have to write. So this total failure management is what we need. Things that you prepare and so on, right? And then implement all these kind of things. Because the center game is okay, right? It's management. It's good for you to understand this, but then let's go to the failure analysis. behave. Okay. In the following situation, good behavior or negative behavior may not change. Right? Assuming the primary is a root cause of problem. Or is a root cause of problem. But that is primary because when you see the kids 4 5 years who can talk already, asking why the level of curiosity is very high. Maybe because they keep on asking until they satisfy with the question, with the answer. Right? But then don't be like just the primary answer that you are satisfied, because your level of curiosity, to develop the analytical mind, to develop the level of curiosity is not there, and then this is something that become the problem, because yes, it is a report, but then it's only the primary report. It must be a proper level. Many cases, don't just simply happy with the primary cause until you do the fundamental theory. That's why it is very important that when you do your study, PhD, master's, once you have the result, you are not satisfied with analyzing or discussion on the result from it, but you have to understand why the result behaves that way, right? So you are, whenever you all the time, they have to do all this kind of thing. And then don't assume. You cannot just determine from by the assumption, guessing. That's why I say engineers, they do test. It's a fact finding. Remember it. Don't use the word I think, I guess. Right? Then you will be cleared by your boss. You say, I guess. How you know this happened? Because it's what I think. Cannot think. Right? Remember it. That's actually very clear word. Collecting sufficient information, collecting sample from wrong location, anything analyze, report, computer, okay, or even you collect information, but that information using the wrong method. They very key, a lot of cases. Refusing to recognize the feeling and or just is it shutting down the malfunctioning, even study failure, no documentation, etc. So this is the fail of failing the system. That means you are not simply going to the failing the system. Okay, next. So achievement. Resistor. Kalau resistor dia macam roti, tapi tu apa dia buat? Point kan? Dia is connected to the board. Kalau you buka board, you nampak ada banyak mungkin kapasitor ke apa semua yang lekat pada board. And then fail. You have to analyze why you fail. This is very important. We have to analyze, right? And then you know that this material is using kind of the tool, as a contact, right? And if you look at this material, maybe not easy to make sure you understand, but then you can see this material having active interface joint, a lot of irregular and large bonds. What's not wanted? Because as a capacitor, they have to send the electron from one to another, but then when you have a bond like this, electron cannot pass through. Electron cannot pass through, and then they get this device overheated because ini semua bukan kata tu. Bila belajar material, you kena belajar thermodynamic. The first law of thermodynamic is that the unity can be created and they can be transformed from one to another. Electron actually not there for this one. They going to generate heat. Right? That's why actually in the house, honestly speaking, I always relate to that. Whenever you want to use for the aircon, they have to use 2.5. If you want to use for lighting, which very low, it's not yet 1.5 to 3. Right? So this kind of thing, because they have to make sure the electron, passing through that copper wire is enough to submit the signal without causing the electrical wire to get hotter, right? And then the plastic will be melted, and then it will be short-circuited. Yeah, so it's so fundamental. Next. Okay. Next. Right. So this is something that sorry that I don't steal it. But then this is something that this is a good picture. 1000 micron. It's very small enough. 1000 micron. That's right. When you look at it, you want to understand why, right? You analyze further by going to 1000x magnification, right? And then you can see the material, right? The silver and then the gold tin and the silver tin. That's what they are. Right? From that, actually, you can see the distribution of material. Okay. You see what this silver tin is a whiskers. These are whiskers. Orang panggil dia whiskers. Ambulance is whiskers. Tajam and needle, right? And then this is gold tin. So they go for kind of analysis. They subject this to the thermal cycle of minus 40 degrees C. Minus 40. You leave it at temperature and then they take up to 155. Test whether how it will be for 100 cycles, right? Minus 40 to 151 cycles. And then go to that minus 40, 155, another cycle until they hit 1000. And then they can see what is the formation of brittle crystal of gold-rich and silver-rich intermetallic compound. So, honestly speaking, ini memang kalau yang kerja dengan industri, dia panggil gold-rich macam gold semua. Gold ni, bila dia work together dengan apa, dia boleh brittle ceramic, bukan metal. That is very important. Can metal be a ceramic? Can metal be ceramic? Jadi kan, can metal be ceramic? Metal boleh jadi ceramic tak? Tak boleh. Metal ceramic? Metal boleh jadi ceramic tak? Okay, I just not, don't worry, I know that metal boleh jadi ceramic. Angkat tangan. Boleh tak metal jadi ceramic? Angkat tangan. Tak ada siapa nak angkat tangan. You tak sure atau tak sure? Ha? Boleh tak metal jadi ceramic? Metal boleh jadi ceramic. Dia pernah dengar tungsten. Tungsten itu metal. Tungsten apa? Tungsten apa? Jadi ceramic. Tahu, tungsten apa? Dia buat dengan carbon, di carburizing dia. Jaga proses ni, ya. Kita ada belajar proses ni. Jadi tungsten. So, ini yang fundamental. Dalam you analyze ni, dia fundamental. Ya, itu penting. Ya. Banyak orang buat PSN dia digunakan pasir graphite, digunakan silicon graphite, dan sebagainya. Carburizing, belajar tak carburizing? Ada kan? Carburizing proses ada kan? Ada. Carburize, meaning that kita ambil tungsten, ambil tungsten, masuk ke dalam apa? Injekkan carbon, and then dia akan jadi shell ataupun case hardening. Because ceramic is a very hard and brittle material. Macam ni, itu fundamental. I'm not going to teach you all those knowledge in the science or the material science. You have to understand that, right? But then when they look at it, they know actually they become very brittle crystal of gold-rich and then silver-rich, right? Sometimes they call mud crack. Dia boleh crack. well done. You know, you can do it next. Dulu ya, many years ago, I don't know where. This is chili dia apa kapasitor ya? Kapasitor kan apa ni? Right, resistor. Resistor ni kapasitor. Ya, ini betul tu. Kalau kita apa ini dalam semiconductor ataupun PCB itu banyak benda. They have to join this into the PCB. This is the PCB. They have to join. They have to ensure that they join by soldering this basic component. It is important, you know, because there's no electronics, there's no devices that function here. They just make sure they can getting the key or getting to the certain capacitance, right? So they have to solder. So when they solder, they have to take a look at this, you know. Then, you know, the device fails. When the device fails, you want to know what is going on. They look at the interface. This one is, they look at it. Right? It's 100 micron. That is the most you don't see at top here, you know. 100 micron. And then why actually they see is so risky? Because last time actually is a thin lead, right? Because lead actually is considered toxic in this environment. You know, electronic industries decided lead cannot be used anymore, right? So they have to use just tin. But tin and lead is between this material and lead. Tin is very aggressive. Without the lead, actually they become like this. It's a whiskers. Misal kucing. Misal kucing punya whiskers tu. Dia tumbuh macam ni. Dia bukan tumbuh immediately. After sometimes they grow. They grow. And this is something that is not wanted because they can cause shorting. Many cases when you have devices, you know, with very, very high IOs, so that means the lead, you know, microprocessor in the device is very, very small, you know, very fine pitch. And once the viscous growth, you know, they going to cause shortage. Right? This is a real 50 micron kind of thing. Next. So, here we go with the viscous, right? You look at the thickness of solar phase, right? You can see how the gold bed thickness contribute to the fractional gold value. So gold is not something that is good to be used. You know the electronic industry they use gold. No, they use gold. That's why you look at documentary, whatever YouTubers or what study, even Malaysia, they like to, you know, they try PhD as a process to extract the gold. Because the gold is not 91.6, the one that actually your mother used actually 91.6 is quite 169 percentage. Because the pure gold is very, very soft. The pure gold very soft. And for industry base, 99.999. 59 they call it. Right? So many gold, right? When you go industries, gold wire and something. It's better to replace because gold getting expensive, more expensive nowadays, right? Last time it's cheap, nowadays it's very expensive. So, but then you know, there must be a reason why, you know, you go to understand on the medical science class. Right? Okay, next. So this is a science and art. Right? I myself is a degree of mechanical engineering. I studied in Australia. When I come back, I will be in oil industries. And then, you know, immediately I feel I have a handicap knowledge. And I pursue my master in science. Because whatever I try to engineer, science does not able to, I'm not able to get the scientific explanation of my engineering product. Right? I try to bond gold wire to the pad, I will be able to do that. When I bond copper wire Because gold too expensive, I want to change to copper wire. I not be able to bond. Sometimes bond, sometimes I can bond. So I, spending like 3 days, 3 nights in the production line trying to solve the problem, and I give up. I think I need to understand the science of it, especially if I can do my master's degree, my PhD in physics. Right? Understand the science. Engineering knowledge is not enough to make understand. So again, science is a journey. Prevention is the goal. Management is failure plus failure management is preventing. Prevention is better than cure. Right? So that means you get fail. Prevent it from failures. Yeah, okay, nice. So again, you look at the system here, identify, define, understand, identify correct action and monitor. Okay, back to that question just now, the one is why go, why you platform, why copper, why question. What is the issue with the copper compared to gold? You material people. Okay? Question, okay. Siapa nak jawab kat sini? Issue. What's really, compare gold and copper? What is the issue? I think you want to take another dia. Right. Tak dapat jawab lagi. Jangan tengok itu. You, who can answer this? Right? The difference between gold and copper. I can bond with gold, I cannot bond with copper. Conductivity, yeah, conductivity copper very good, but then he doesn't explain why I cannot bond. Conductivity of copper wire much better than gold, right? Sini siapa boleh jawab? Ni, mas student. Okay, people want to use copper than gold because copper is cheaper, gold is expensive. Copper has very high electrical conductivity, gold does not have. But then one thing, copper is easily oxidized, gold is not. Some people still believe gold is oxidized, right? That's why actually, sometimes they send to the lab. I said, I want to see whether my gold is oxidized or not. I said, don't waste time. Theoretically, gold never oxidized. That's why actually gold be used. Imagine that you use jewelry as copper, oxidized all the time. You have to do brush like brass, you like tembakau or something like. They selalu dinamakan because that's actually copper and other material. That's why people use gold. Even gold nowadays is not yellow color. People want to use a white gold because they never oxidize something like. So this is something that you have to understand this, right? And why is copper not oxidized? Gold is not oxidized. You have to learn material. When you learn material, you have to look at electron. What electron to do? Valence electron. Whether they become the ionic bond, covalent bond, or something like that. This kind of stuff. Whether they going to attract oxygen or not. It's the first thing, when you do this one. Okay, I don't want to talk too much about it because today is on failure in the test. Okay. So you will get very familiar because fish bone diagram. Nama ikan lah. Fish bone diagram. Maju belajar lah bone diagram. Because this one they talk about cause and effect. Right? They look at the 4M. Human, sheep, material, man, and method. 4M. Ini measurement okay lah. You what we pun, you must have 4M. You must have abon, right? You must have tepung. You ada abon yang bagus, ada kita tepung itu tak kering betul, tak jadi. Right? The same thing. So that's a very simple thing. You want to make bun, you want to make whatever, not be able to make it because that. But then next. Okay. wafers dalam chip level ni semiconductor itu why actually very important as semiconductor devices. Semiconductor atau electronic industry in Malaysia is considered one of the biggest exporter in Malaysia. We are the country that we identify that produce all the electronic chips in the world, right? And genetics, even the Raku, even they spend another period, right? And then Intel, everything, right? They are doing the process here, manufacturing here, and this continues. But then, it's dependent. Depend. If the man is not ready, because your generation is a man, right? My time, I retired, so I cannot continue my legacy in the industry. Many people will retired, right? So they will need people not dead. You want to PP, for example, what the PP can be doing at night, for example. Not necessarily, must have light, for example. Create the light and we do the energy harvesting because of the conversion, become very, very efficient. So in the semiconductor, you do the electrode, fab, semi-test, and all these relative tests. I'm very familiar with all this, right? Because I myself not only in the packaging, I was also in the fab, right? German company, right? So these are process. Don't have to understand this one. And these are the things that you do. Next. So role of role of engineer to drive for low yield elimination for the activities. Just now I talked about the loss of millions of dollars every month, because of yield. Yield is a process of productivity. If you process 100 units, you have to get the 100 unit out. If you process 100 units, only 90%, 95% out, 5 units depends. That is a cost. That's a cost. So as an engineer, you have to make sure that you try to eliminate. If you produce 100 units, okay. If you produce 1,000 units, okay. You produce millions of units. Even if the one particular unit costs you 20 cents USD, millions of units, going to be very, very costly. Because you based on material, you based on process, you based on people, you based on equipment. So, solve customer complaint. This is what you want I mentioned just now. Right? You send the product to customer, they test on the car, suddenly the EV car exploded. Because there's one system, they call it battery management system, what we call it. They manage the battery. Because the car battery, for example, they have 6 modules. They will decide, the BMS will decide which module they will to charge, which module is low, which module is high. And they have to tell which module of the battery is having high temperature. Remember, because when they charge this one, they pump it left or right. They pump it left or right, they pump it left or right, it's generated. So how much voltage they want to put in? They have to balance it to the battery management system. If battery management system fail, the car will explode. Get exploded. Honestly speaking, that's very, very good. Yeah? That's still, on top of that, make energy transfer. You have to understand. Release of product reliability is very mechanism. Improve cycle time of real system a long time. P80 they call it, right? That's not actually as of FP, right? If they have problem, you send to the engineer with the failure, and then they have to do it, in 3 days. Production is waiting, the production is shutting down. You cannot do it in 3 days. You have to do it in hours only, right? So development team from contributing to design for failure analysis. So this one, that's what changed the evolution of technology, as an exercise or as a concept for you to work. pop up, like what? Nothing much. Because they have certain things. Next. What is critical difference is relatively, different solving problem solving approach, understanding information of the tools and maybe operate a variety of analysis tools. This this is just kind of the awareness. But when I go to the industries, I ask what is it today using to analyze this more? Are using SCM? You know what SCM? Scanning electron microscopy. Dia kan belajar macam metodologi yang belajar, metodologi sorry. Dia belajarkan SCM, scanning electron. How actually you look at the device or you look at the product in the magnifying things. You want to magnify the product. You know what biasanya? Microscope, right? What is the source of apa tu yang digunakan untuk microscope? Digunakan light kan, cahaya light. So your knowledge up to that one akan beritahu lagi the next level of looking at the device or looking at the product at higher magnification. Siapa tahu dia gunakan apa? Dia tak boleh gunakan photon, tak boleh gunakan cahaya lebih dah. Cahaya dia ada limitation, dia boleh pergi pada 100x berapa ni? Tadi ada sampai 500x, 1000x kan? That magnification. They don't use source of lighting atau source of apa ni? Pakai light. No matter how bright LED they have to use what? Electron. They have to use electron as a source for you to look at the bigger magnification. Electron kan dia baca dari electron, menarik sangat. Nanti tak boleh next. Okay, so you have to look at the failure mode, failure mechanism, and the root cause. This one yang kita dah upload tadi. I need to look at you techniques in that. Next. Okay, sometimes the device is very expensive, it can be destructive. Maybe dia juga analyze pada yang apa tu dan dia rosak terus. So you have to use non-destructive, which doesn't cause any permanent change in the sample. Destructive, you guna, you test, you're not able to get the device back, right? So this, whether you want to do non-destructive or destructive, please open. Next. Okay, entry. Business process. I, as a team of the failure analysis, having 30 engineers last time, and a lot of customers, the engineer come to us, asking us to analyze our and of course, we cannot entertain everybody, so we come up with the business process. Customer ni dulu supaya customer tak complain at the end of the day, right? And we should be able to deliver the job. That's why sometimes they say, I want you to check. Then I tell the people, you don't tell me what to do because you're not the expert. I'm the expert in the failure analysis. I tell you what to do. You just extract the problem. Very important. They don't have this kind of knowledge on the failure analysis, but they have a problem. But based on their limited knowledge, they just ask us to do this and that. But at the end of the day, it's a waste of resources and time. Yeah? So don't tell us what you want us to do. Tell us the problem and then we tell you what to do. Always is one of the keywords that I always use. Yeah? So once you read that, you can understand it next. Okay, there's a process control. Right? So the same thing, how the procedure. We come up with the very strong SOP in the failure analysis to make sure, right? We make customer happy, but we very careful in the failure. Next. Okay. Once the device evolution become higher and higher, whatever the current business process is not enough. That's why all this thereby stuff. Whenever you do the failure analysis, you have to develop certain method. The current method may not be good enough. If you, for example, last time there's no battery management system, so you have to come up with a new method, a new the lab, they have to come up with, you know, for example, technology continuous material design, come on, process strategy, process manipulative, certain things. That's why sometimes, you know, when you pick people high level directors, you know, this guy don't even touch, don't even touch the process, but then they are highly paid. You know, 30,000 for example. It's common, you know, in the industry. Right? They ask us, you know, they pay you very high, but then, you know, you just make certain decision. But the road is not that simple, you know. We have to make sure that we get ourselves prepared for it. Whenever there's no time or doing this one, you know, coming to the industry, and we have to get ourselves ready. Don't tell, oh, everything is not ready. Imagine that, I say that, you know, to the organization. Everything is not ready, something that I ready. Next. Okay, next. I like to show this. You know, it can explain 1,001 words. You know this kind of thing. Who can tell what is this? What is this? Yeah, I'll give you 1 minute. Who can tell me what is this? Satu. You nak jauh lagi sikit? Boleh? Calculation technique, you know. Ni apa alat-alat yang oh, projector. Okay. Dia adalah but that is actually characterization equipment. You know, imaging equipment, not only imaging, but have to look at the spectrum. You know, bila imaging dipanggil microscopy. Bila you look at the spectrum, they panggil spectroscope. Spectroscopy. Microscope is very important. Alright? So, yang you pernah dengar, yang you pernah tengok, tak ada yang ini dia play around with the electron and also ion. What's the difference between electron and ion? Another question. Pernah dengar tak? Material yang mana dipanggil elektron, satu lagi dipanggil ion. Apa ion? Ni tuduh je, apa dia beza dia? Apa elektron, apa ion? Macam ni, ada apa-apa, boleh bagi jawapan? Very important. You not be able to differentiate. Nanti kalau you tengok dia itu nak buat. You cannot do that. This very high level. This jadi is the techniques ataupun characterization yang is always digunakan. But then, you know, people to have all, none of the company can afford to buy this. Very expensive. For example, if you want to do imaging, right? You boleh pakai imaging gunakan focus ion. You gunakan ion as a source. You boleh gunakan SEM, gunakan intense, you know, kita ada dua itu scanning electron microscope. But then you want to go of even high resolution, you cannot use scanning electron, you have to use transmission electron. Atau scanning transmission electron, ini high level, right? And then you boleh gunakan SPM macam, you know, you image pakai touching control to dia nak semua boleh touch saja boleh image dekat mata dia. So this imaging, right? Okay. But then you want to look at the material. Material, there's no such thing material as a pure material. They consist of you boleh gunakan step EDS step tadi itu sini. Dia ada satu function yang mana kita panggil electron EDS, dispersive spectroscopy. Dia image mendekat elektron. Elektron tu boleh digunakan tadi untuk tengok elemental. Elemental tu ada dekat compound dengan elemental. Digunakan OJ, electron spectroscopy. OJ ni nama orang, dia OJ. Ya. Dan dia boleh gunakan raman. Raman ni nama orang seperti India. Dia digunakan raman spectroscopy. Digunakan X-ray photon electron spectroscopy. Boleh juga. You know, there are many scientists in this world. Some of the techniques, different way how they can analyze it. They could buy what they did from it, but they know on my level, I have this thing. And it's not just this I read from the book. It's all that I experience. You know, I have this book. And then they have SRB, X-ray dispersive, then SRR, tak pernah cuba. Dopot dan scattering, SRF, Fourier transform, kita ada di sini. Right? And then type of flash, secondary reflection, secondary ion, mass spectroscopy, ICP-MS, SRF, itu adalah teknik-teknik yang digunakan dalam kalau you gunakan yang besar sikit, yang dia boleh pakai ICP, OES, you gunakan gas chromatography, mass spectroscopy ataupun NDA sebagai bahan ini, GDM, macam teknik buatan. So, anda kita tahu dia apa? You boleh detect kalau dia ada satu dalam sistem kita, kan? Dia boleh gunakan 100 parts per trillion. Kalau atom tu ada 1 trillion, tiba dia ada satu boleh beri. Kalau material tu apa ni, dia boleh gunakan 4 billion. Dalam billion of atom, dia boleh check 10 billion. Bayangkan, you know, kalau kaji ini cerita billion bukan cerita billion dan trillion tau. Atom tu kan apa dia boleh check. Tapi kalau dia gunakan dia persen aja, contohnya, for example, semiconductor, semiconductor, dia ada p-type inside. Semiconductor ni, kalau you buat transistor, dia ada p-type inside. Dia akan dosekan, you know, sama ada phosphorus, dia boleh dosekan, you know, arsenic, dia boleh dosekan a few others, you know, dalam atom, dalam semiconductor. So they can change the effect of semiconductor. So kalau nak tahu ada kepada, you have to do this, right? Dynamic sim ada dekat memori, right? Tausin ada memori juga, right? Yang ini biasa kalau ni pun ada dekat memori, ni ada dekat memori. Sebab memori yang apa tu, I punya Z. So, apa yang dia nak? Bila alat-alat ni, dia will give different interpretation. Imagine that, jadi you nak tengok sama ada tak phosphorus dalam device. Right? Sedangkan kita tahu dia selipat berbeza dia digunakan alat. Never going to get it. Dia kata tak ada. Dia tak ada. Tak ada. You know, I use this, but then not be able to detect. That means, you know, your conclusion, there's nothing inside there. But then, because of the tool that you're using is wrong. The one that you sensitivity is about 10 atomic percent. Yang you nak tengok is 100 billion. Itu tengok dari satu sudut. Tetapi kalau if you want to take a look at this, or you want to understand it, you will take months, you know, to understand all this. Because each one of them they have dia berlaku lepas perang, nama dia OG. Dia sama dengan Marie Curie, buat sama, tapi Marie Curie mati dulu, lepas tu dia yang tahu bila konsep OG. Dia very surface sensitive compared to DDS. Tapi pada DDS ni, OG ni boleh buat dia profiling. Kalau cerita panjang dia tak boleh apa, yang ini dia boleh cerita, you take days to explain all this kind of thing. But then these are the techniques that if you are in the FA or you're in the electronic industry, you have to understand and make use of it, right? So basically, it's not just completed when you finish your study. The journey will go on and on and on and on when you work with a lot of right? And this you as the next level engineer that you have to perform. Otherwise, you take up and then go somewhere. Okay, next. So, in order to adapt, I would say very simple. That you measure what you the response. But if you prove it right, then they will respond. Very important for you to prove using the right technique. Okay, so this is what I say in common criteria. This one is the simplest one that you have seen. And for microscope, like a bar, indentation we have here, transmission. This equipment, last time when they built this equipment, two-story building, because they have a very high power gun, high electron gun. They have to use high electron gun, 200 eV electron voltage, 200. So they have to penetrate the sample, and the sample they have to prepare in such a way that imagine that you want to make a membrane, you want to make a membrane more than thickness. You have to make it, otherwise you can't do it. How seen, as what I said, I don't like this human because they don't give me really, because that's what they do. Like SPS, CISCA, SPS, CSCA, you know why it's needed for SPS. Okay, next. Another. I always tell you, engineer. Normally, engineer is the electronic industry. Electronic industry, they want to analyze the sample. They want to analyze the sample in such a way that they use SCM. But when I want to see copper, for example, just now, I mentioned before, copper that oxidizes as well. I want to know whether the copper, on the surface, it's really oxidized. So they become CuO or Cu, copper oxide or copper dioxide. I want to know whether my copper, for example, this one, my copper really on the surface is copper oxidized. So I'm using SCM, then acid oxidized, but may not be true. May not be true, Copper, when I'm using SCM, because the pH of penetration, is up to 100 nanometers. So I'm not able to really check on the top surface. Right? And I make wrong assumptions. My copper is oxidized, but then oxidation, not on the surface, but then inside here. You got my point, or not? Because in semiconductor or in the pH, the one that really is our point of interest, our concern is on the oxidation on the top layer, because they have connect on other material. If my oxidation actually go inside and then I say it's top, then I'm having problem, wrong interpretation that I'm using. So always they say compositas and so on, but then if I want to know exactly on the surface, I have to use this one. Or even on the near surface, 10 nanometer kind of thing, OJ, SDS, ASRF, and so on. So this is very important. Normally in the semiconductor, people, because of the lack of knowledge, they simply set the certificate, then buy SCM test software. That's why when I got this whatever equipment that is not there, I always go with university. University have all those equipment, but we don't know what to use with it. We just buy, but then just that's the thing. Yeah? Alright? So, of course, I'm not going to tell you all these techniques. There's something that's another comprehensive course that you can understand. But it's very interesting. Next. Okay, these are the comparison on the techniques of this, right? The GDM. Very interesting. That's why I say signal detector is X-ray. What they say? Electron, secondary ion, and molecule. Element that can detect. Not all elements can be detected, especially hydrogen. Right? You want to understand the concept of SCM, for example, they use secondary electron. But then hydrogen only one element. How is it difficult to detect hydrogen? The lighters, you have to understand the periodic table, look at all that. So the journey is part of it. Next. So this analysis consideration, here, position, confirmation, there are a lot of things. Right? Next. Okay, size, religion, figures, outer space, so on. Next. Okay, let's go to the overview. Next. Okay, we go further. We define EFC. Next. Okay. Later on, we take a look at the example. Next. Right. Draw the flowchart. Why we do until you use and you don't know what you're doing. Just any job, because you don't know what to do with this. The networks mentioned. Okay. I want to show you on the next one. Next. Okay. Just now we talked about the material. But then during the flow, there's something just so many things that we have to do. There's so many things that we have to get. You have to do a tester for electrical X-ray. Yeah, you have to do the check chemical. It's a polishing chemical and phosphor. Chemi, IR, object physics. See, so many things, yeah? Right? Okay.